So before going to discuss about resources of geothermal energy, what are the considerations or how the geothermal energy sources are classified based on mainly three. First one, temperature. So what is the temperature range of the geothermal energy? Next, second one, physical state of H2O is nothing but a liquid state or steam state. Okay, physical state of H2O is nothing but a liquid state or steam state available in the geothermal reservoirs. Okay, next, type of energy usage. These are the main three considerations which we will take in to classify the geothermal resources. So maximum will depends upon the classification about temperature range. So there are mainly two temperature regions are there. One is low temperature reservoir, high temperature reservoir. So low temperature reservoir is having 50 to 200 degrees Fahrenheit. That means if we will convert into degrees, 10 degrees to 94 degrees centigrade. So below the boiling point temperature of water, we observe 10 to 94 degrees is nothing but the below boiling point temperature of the water. After 100 degrees the water is converted into steam or steam. So that is called low temperature reservoir. The range of the temperature is 10 degrees to 94 degrees centigrade. Next, high temperature reservoir. So high temperature reservoir is nothing but the range of the temperature is greater than 200 degrees Fahrenheit. That means more than 94 degrees Celsius. Okay, these are the two main primary classification of temperature resources of geothermal energy. Okay, next, so in the nature it is available in hot water reservoirs. So that is nothing but geothermally heated underground water. So next, natural steam reservoirs. So if you observe here, hot water reservoirs is nothing but having the first classification regarding temperature. That means below 94 degrees, above 10 degrees temperature. So natural steam reservoirs, instant steam, but they are very rare. So instant steam, so no need to use extra heat to convert the water into steam. So already it is available in the nature itself as a steam. So if you observe here, this is a high temperature range. Next, geopressurized reservoirs, normal geothermal gradient, hot dry rock, molten magma. So hot water reservoirs, reservoir means is nothing but a storage of water, is nothing but a reservoir. So hot water reservoirs, as the name implies, these are reservoirs of hot underground water. So there is a large amount of them in the US as well as all over the countries maybe, but they are more suited for space heating than for electricity production, because I already said the temperature is below 94 degrees, above 10 degrees. So it is used for space heating or cooling purpose in different countries rather than electricity production, because electricity production is needed steam state of water. So that's why this is hot water is nothing but a liquid state, so it is used for space heating or cooling purpose. Next, natural steam reservoirs. In this case, a hole dug into the ground can cause steam to come to the surface. This type of resource is rare. In the US is nothing but America. So I already said that direct steam is available in underground reservoirs, and which will extract by different equipments, so which will use directly to different applications, majorly for generating electricity or production of electricity. Next, geopressured reservoirs. In this type of reserve, brine completely saturated with natural gas in stored under pressure from the weight of overlying rock. This type of resources can be used for both heat and for natural gas. So not only the geothermal energy is not only used for space heating and cooling for production of electricity. Natural gas also we will extract by this geothermal energy is one of the conversion of natural gas. We will extract natural gas also by using geothermal energy sources. So normal geothermal gradient at any place one of the planet, there is a normal temperature gradient of plus 30 degrees centigrade per kilometer. So when we are going to deep, every kilometer it will add 30 degrees centigrade dug into the earth. Okay, therefore if one digs 20,000 feet, the temperature will be amount 190 degrees centigrade above the surface temperature. So this difference will be enough to produce electricity. However, no useful and economical technology has been developed to extract this large source of energy. So up to now there is no developed technology to grab this or to extract this large source of energy. Next, hot dry rock. This type of condition exists in 5% of the US. It is similar to normal geothermal gradient. Here thermal gradient is nothing but a difference. So thermal gradient is nothing but a difference between the temperature, or difference between the temperature and difference between the distances is nothing but a thermal gradient. So temperature and distance differences is nothing but a thermal gradient. Next, molten magma. No technology exists to tap into the heat reserves stored in magma. The best sources for this is in the US are in Alaska and Hawaii. So molten magma, I think all of you know well. Magma is nothing but we will get magma or lava, both are similar. It is available in the volcanoes. Okay, which is very hot liquid state. Next, these are the main reservoirs diagrams. So geysers, boiling mud, hot volcanoes, hot springs. So these are the places which are suitable to extract geothermal energy. Okay, next, if you observe this diagram, this is ring of fire. Ring of fire is nothing but the surrounding places of Pacific Ocean is very suitable. So here you observe the red color indicates that the geothermal energy available places. Okay, so surrounding place of Pacific Ocean is very useful for extracting the geothermal energy. So this place is called a ring of fire. Okay, next topic, types of wells. So wells is nothing but the path to the reservoir. How can we create a wells, or how can we create a reservoirs? So first one, drilled wells it is constructed by either cable tool or rotary drilling machines. So these types of wells are created by normally we are seeing the borewell machines na. So like that heavy machines are used for create this type of wells. So in drilled wells the maximum distance we can drill up to more than 1000 feet deep. So more than 1000 feet depth we can drill by using different drilling machines. Okay, so next, the space around the casing must be sealed with grouting material of either neat cement or bentonite clay to prevent contamination by water draining from the surface downward around the outside of the casing. So the prevention is very important. Next, driven wells. These are the one type of well which is having maximum limit of 50 feet deep or more. So these wells are created by using two methods: hand driven wells and another one is machine driven wells. So hand driven wells usually are only around 30 feet depth. Next, machine driven wells can be 50 feet depth or more. Okay, so driven wells are constructed by driving a small diameter pipe into shallow water bearing sand or gravel. So shallow is nothing but the depth is very less, so very little depth is nothing but a shallow. So this type of driven wells are having only 50 feet to or more. Okay, so if we consider drilling wells which is having 1000 feet or more. Okay, so compared to drilled wells, driven wells having less depth. So dug wells is nothing but like compared to drilled wells, driven wells, it is having very less depth. Okay, so below 30 feet distance we can dug this type of wells. Next, so these are the different applications or uses of geothermal energy. Actually I discussed in last class. So these are the temperature range. If you observe here, the temperature ranges under different applications. So next, uses of geothermal energy. So already we said here, these are the different applications and different temperature ranges. Based upon our applications or uses, we can use this type of geothermal energy. Next, uses of geothermal energy is mainly two types: direct use, indirect use. So geothermal energy direct use is nothing but geothermal heating, space heating and cooling, heat pump or swimming pool heating, stable heating, drying of vegetables, etc. So indirect uses is nothing but electricity production is an indirect use of geothermal energy. So direct use, heat is directly used. Heat is extracted from low temperature source. It can be used for space heating. I already said na, heat space heating, industrial process, drying crops, hot water supply, melting snow. So different uses. Indirect use is nothing but electricity production. So the source temperature is higher than 150 degrees centigrade. Deep